My name is Albert. I come from Malta. It's a very small island in the Mediterranean Sea. I moved to Germany just to join Thoughtworks. This was November 2018. Today I'm going to be your host for Domain Primitives. So, as my colleague Stephanie already said, if you have any questions or you would like to ask anything or go off a tangent, please do so. The best time to ask your questions is when you have them. So, so today we're going to be touching these areas: data representation, ambiguity, security, and tight coupling. And at the end of the session, we're going to talk a bit about shortcomings, because it's very easy for me to just praise a technology or a technique, but everything comes with a price. And when we're working, it's very important to keep the cost, the price that we're paying in our mind, because sometimes the cost of a technology may be higher than the actual gain we're going to get, and we end up spending more money or effort and gaining very little. So let's start. Data representation. So say I have an order number, and this order number is usually a 10-digit number, as we saw in the first example here. But there are cases where the order number can include a dash. And these are some special cases. In this scenario, we have a build to order, it's called, or a build to stock. Just for your information, something a build to order is that where we're manufacturing something and there is already a client for it. Whereas when we're building to stock, we don't have a client for it yet. This is going to go on a shelf. And now let's say that we need to represent this in our code. What data type we're going to use? The first thing that comes to mind usually is a string. String is our catch-all data type. It can support anything. Sometimes we use strings for dates as well. And here are some examples. The language we're using here is Kotlin, but it applies to any other language. So we have an object here of type order, which takes the order number as a string. We have a gateway, which we can use to retrieve orders from other systems, and again takes the order number as a string to the fetch function. And we have also a repository, in this case with just one function called delete, which too takes an order number as a string. This is quite typical, and you're going to find this technique in many other places. Sometimes if it's not a string, usually we use longs if it's just a number, or an integer if it's just a number. So what's the problem in doing so? One of the very important things that we need to appreciate when we're using language primitives like longs, strings, or things like that, is that these are very, very big. They capture a big set of values. Whereas in our case, order numbers, they are special strings in the sense that an order number needs to have, for example, 10 digits. In a string, I can put anything. I can put my name. I can put my email address. I can put, I don't know, what Shakespeare wrote hundreds of years ago. And so the data type, the string data type or the long data type, they are quite big. They are too generic for our case, and that can cause some problems. Take this example here. I can easily create an order and give it any random string. This will compile and the order will be created. Of course, you're going to tell me that this order doesn't have an order number. That's not an order number. That's just a random string. Same applies to the gateway. The fetch method, I can feed it any string. It can be blank string or long string. Same applies to the repository. The above code will compile. I know what you're thinking. You're going to tell me, yeah, like we can have validations, for example. And yes, that's usually what we do. We create some validation classes. We have some validation functions. They check and they make sure they can either, for example, as we have in this case, they return a true or false, or fail with an illegal argument exception, as we have here. And this is quite normal. Sometimes we also use annotations for validations, and that's all quite common. Here we have some example of how we can use it with Kotlin, where we can put, in case of the data class, we can put it in the init block. And in this case, if we try to create an order with an invalid order number, like with any string, which is not an order number, it's gonna fail. Same applies to the gateway, same will apply to the repository. What's wrong with this, you will ask? Like, this will work. Sure. This approach, unfortunately, will pollute the tests. Why? Because if you're gonna put validations within functions like the fetch order or the creation of the order and the initialization, you are passing responsibility of validation to these objects. So now, for example, the order creation, let me just go on back. Here in the order creation, I need to make sure that I am validating the order number. Therefore, when I'm also writing my tests, I also need to make sure that when I provide an invalid order number to the orders data class, this will fail accordingly. Same applies to the gateway. I need to add tests to make sure that whenever I give it an invalid order number, the gateway fails. So what's going to happen is, everywhere where I'm going to be using this order number, I also need to add tests to make sure that the functions receiving this order number, they are failing accordingly. And we end up having a similar test for added to every place where we're using this order number. And we end up polluting the tests. This is because we added responsibility to these functions when this responsibility did not belong there. Let's shift a bit for a moment, and let's consider this function here. Say that we have a function that takes a string, and you can see it from the name of the function as well. Can you call this function and give it an integer, for example? No, because if you try to do so, the compiler will fail. The compiler is going to tell you, no, like, you can't pass an integer there. This function takes a string, as we can see in the function signature. So do you need to write a test for this function? No, you don't have to, because the compiler is going to flag it out. When we are working in a system, the test pyramid, it's brought up a lot to help us determine where we should put our testing logic. In many cases, unfortunately, the testing pyramid doesn't capture the compiler or linter in case of languages that do not compile. The compiler can act as a test mechanism for us, because it's going to test to make sure that our code is syntactically correct. So if I go back to this example here, if I try to pass something which is not valid, in this case, I try to pass an integer where I was required to pass a string, the compiler is going to tell me, no, you cannot do that. Can we use the compiler to our advantage in the problem we had before with the order numbers? And the answer is yes. Instead of using a language primitive, such as strings, we can use a domain primitive. Domain primitives, they have this feature where, I think it's best if I move to the next slide. Okay, the domain primitives, they have this feature where they make sure that each instance that we create represents only valid values. So here, as we can see, when we try to create an instance of the order number, here we're making sure that the string that we provided is valid. Let's see how we can use it, and I'll explain this in more detail as we go along. One of the questions I get when we talk about domain primitives is, are these value objects? They are very similar. Domain primitives, sometimes they are referred to value objects, but there is a very important difference, as I was saying before. In value objects, usually we capture information like money or address or anything that we don't have in our language primitives. But one of the great difference of domain primitives is that each instance that we create needs to be a valid instance. We cannot have invalid variants of domain primitives. So in case of our order number, it's not possible to have an instance of an invalid order number. So in other words, if you try to create an order number with 9 digits instead of 10, it will fail. And the constructor will make all the validations, it will check everything, and it will fail if the given string is invalid for any reason. And this makes sure that all objects, all instances of our order number are valid. It's also very important that the domain primitives are used just for one thing. For example, we cannot have a name domain primitive for multiple things. Say, for example, that I have a person and a computer name. Can I use one domain primitive to capture both? No. In this case, you need to have two domain primitives, and even though they will look very much alike, you need to create different ones. We will see later on why this is important, and sometimes we try to optimize in terms of code, but then we will be opting out from some benefits. How can we use them? It's quite simple. Instead of having a string, we have an order number. So now the type of the parameter, it's not string, it's order number. Same applies to the gateway, to the repository, and to anything, anywhere else where we're using this. Now we can take advantage of the compiler because we cannot anymore pass a string, a random string, instead of an order number. The above example will not compile because order is expecting an order number. Furthermore, order number is making sure that when we're creating it, it's verifying that only valid instances of the order numbers are created. Invalid instances are not allowed to be created. This will safeguard, and this is gonna shift now the responsibility of the validation from the consumers, in this case was the order data class, and it was the gateway, as the order gateway and the order repository, to the order number itself. One of the benefits on doing so is that we're going to reduce the test pollution. Now we're going to concentrate all the testing related to validation of order numbers in the order number validation tests. Not only that, this is going to group, this is going to document what makes a valid order number, because just by looking at the test related to the order number, we can tell what makes a valid order number or what makes an invalid order number. And if there is some ambiguity, we can express this, or we can eliminate this ambiguity by tests, which is the best way to do it, because tests cannot go out of date. Why? If a test is invalid, the test is gonna fail and stop the build, and the developer has no option but to or fix the bug that was introduced, or if not fix it, they need to adjust it. So let's say that some new business rule was added there, and now we need to add a new condition. A new test will capture that, and whoever needs to understand what is an order number, what comprises an order number, can just look at the tests. In the past, I used to use lots of documentation. You know, I used to write Java docs, or I used to write it in some wiki page. The problem with these approaches is that they get outdated very quickly, especially with a very high evolving system. I see that we have some questions. If Manfred can mute, please. Thank you. Another option that comes with Kotlin is seed classes, and usually I'll go for this option because they are neater, and I avoid from throwing exceptions. Unfortunately, the example tend to be a bit bigger and won't fit in my slides. That's why I didn't use them. But this is a better option where you'll have like a sealed class, in this case, an order number, and then you have two variants of it, an invalid variant and a valid variant. In the invalid variant, you can capture more information. For simplicity, I just have an order number here, but we can capture more information which describes the problem. And here, the valid instance will only be returned when valid order numbers are created. This simplifies the use. As you can see here, we can streamline usage. So if we try to create, as I did here, an invalid order number, the invalid section will be executed. This code is not complete, again, because it doesn't fit. And due to, it's very hard to fit it in the slides. Another thing that it's not mentioned, or sometimes doesn't get the attention, is usage. If I want to determine whether something is used or where this is used, like if I just use language primitives like strings, basically, it's going to be hard for me to find where the order number is used. Why? Because I am relying on the fact that order number is written order number. And if in some other place I wrote number, or if in some other place I wrote ON or misspelled it, it's going to be hard for me to find where this is used. Whereas if I use a domain primitive, if it's a type, it's very easy for the IDE to tell me where this type is used. Usually right click on it, on the field, on the class name, and tell it find usage. And it's going to list you anywhere. And this is quite handy, because if I want to retire something, let's say I would like to deprecate a task like a domain primitives, I can annotate this deprecated, for example. I can create my new version and easily then migrate from my previous version to the new one. Or I can take it off if needs be. If you just have strings, you don't know where this is used, or it's going to be hard for you to find where this is used. And yes, you can rely on tests, that's true, but it's going to be hard for you to plan ahead. Like if somebody comes on you and tell you, okay, if we remove or change this field, what's going to be the impact? How much is going to cost us? If we use domain primitives to describe your model, it's going to be very easy, because you can go there, you can check the usage, you can see how deep this is used, and then you can plan accordingly. That's good. That concludes the first
Albert?
part. Yes.
We had a question from Manu, and that was the same question I had as well. Do you want me to read it out to you?
Yes, please.
Manu's asking there that, is this check performed only at compile time? What if the order number is coming from a user input or an API call?
In this case, you can, if you use sealed classes, as I showed here, in this case, you're going to have the invalid variant, and you can handle that. You can say, okay, like you can reply something back to the user. If it's a REST API, for example, you can return some 400 error, or to indicate the user that this was an invalid request, or can provide even some more description there. And if it's valid, in that case, you can handle it. You don't. That's when I. That's why before I said I prefer the sealed classes option, where I capture both the valid and the invalid variants, and then I deal with them over exceptions, because they make the code more streamlined. But in this case, if I'm going to go with this approach, my for example order number, my order data class, instead of taking order number, it will take order number.valid. So even though there are two variants of your order number, the invalid ones and the valid ones, you can then specify at the, for example, at your gateway, at your repository, that you only accept the valid variants. In other places where you would like to handle everything, you can accept them both by accepting the order number, by having using the type of order number. Does this answer your question, Sean?
Hi.
What you're saying is it just makes you think a lot more intentionally about your code. So you intentionally handle these kind of cases because you have both valid and invalid options.
Yes, and also you can program your code, like your when cases, in such a way that they will need to return something. So they are exhaustive. If you include a new variant, your code will not compile because you need to handle all variants. And that's a very good way, because if you don't need to write tests for this because the compiler is taking care of it, which is great. And secondly, if you by mistake forget to add a variance, a catch somewhere, like we have here, again, the compiler will highlight it.
All right, thanks.
You're welcome, Sean.
Sorry, maybe it's a bit too technical, but what's, in your opinion, what's the benefit of having this sealed class variants instead of just having something like optional of order number and don't deal with this?
The optional is going to give you whether I have it or I don't have it. Whereas with the sealed approach, let me go just a little bit back. With the sealed approach, I can have more than one invalid option. So I can, for example, differentiate different types of errors. I can put more description. Like in an optional, I'm gonna have whether I got it or I didn't get it. The error is gonna be missing there. For simplicity here, I didn't include any information, but you can include the problem, like why this is an invalid. Is it too long? Is it, for example, let's say that in our case, the first digit had to be one of two values. It's either a 0 or a 6, for example, because that has some business value. So if you start with a 5, that's an invalid. And you may report back as part of the detail here what makes that invalid. Whereas with an optional, you cannot do that. Does this answer your question?
Well, you can use either. I mean, I don't know Kotlin, but it's in Scala there is either type, right? So that was more of the question. But
and then you return the error, you mean?
Yeah, either order number or error, right? Left or right.
Yes. The sealed classes they provide you more options, because here I only have 2, but you can have more than 2. Anybody would like to ask anything else?
Yeah. There was a follow-up question. Thinking about a bigger object which have a couple of domain primitives as fields, and we want to deserialize JSON and instantiate the object, how do we use valid, invalid variants in this object during deserialization?
If you have complex objects, it's going to be a bit more challenging, because something very down the stream may be invalid, and that can be without having any business knowledge. Is going to be hard to answer, because it depends. I had a case where I had to parse big amounts of data, but there were cases that if part A of this data was invalid and I'm just working with part B, that doesn't matter. I will use part B and ignore part A. So it depends a lot on your usage. If you need to have all your object valid, then you can create one immutable object and have the invalid and valid at the top rather than at the edges. But again, this depends on your usage. I don't know if this answers your question. And if you want to give me an example or...
Hello? Hello? Yes. I was wondering about how do you think about the data access layer, because you were talking about the business layer primitive is very suitable for a business layer and business exception. But you know, today there are a lot of ORM tools such as entity framework and Hibernate, and but this type could not help to for these tools, because object-oriented and ORM has a basic concept, and this value is not suitable for ORM tools. Thank you.
Unfortunately, this is going to be also shown in the shortcomings. Unfortunately, when you come to interact with other libraries, this is going to be very hard for you, because serialization or using other libraries, they're not going to be knowing about your domain primitives, and no, you need to translate them yourself, and that's one of the shortcomings. But this purely applies to your business layer. It does not apply to your edges. Like even when you're leaving your system, when you're sending something to JSON, it does. I rarely used the domain primitives for that, because they are not suitable. The goal of the domain primitive is to model your data model, basically. Whereas when it comes to repository, I think it's best to have another model which is purely optimized and aligned for your persistent layer. Now, if that's NoSQL, that can be just like a normal bean sort of. But whereas with it, when it's and then it's converted to JSON, but when we're talking about relational database, maybe you need to have another object which is more in line to that persisting layer. So I am much more in favor of having specific objects that serve specific purposes. So if I want to use this with an ORM, I would have yet another layer of objects which are purely a representation of my tables in my project.
Thank you. Thank you.
Any more questions?
Yes, there are some questions. First one, I think we didn't had this one. It's from Jacek. I hope I pronounced the name right. How those domain primitives are different from any custom type I can create. Just by looking at the code, I cannot really see the benefits over how my Java code would look like.
The one very important criteria of domain primitives is that domain primitives, each instance, need to be valid. It is very important that it's impossible for you to create, for example, an invalid order number. So if I have an object of type order number that is valid, and whoever is receiving it doesn't need to worry about it. This is the most important thing. This is the added value that you're gonna have. So if I see my function here.
But in Java, I could do it as well in my constructor. The constructor either returns a valid object or throws an exception.
That's true. If you make sure that the order number in this case is valid, then you created the domain primitive. A domain primitive, like I don't need to rubber stamp your class, so it becomes a domain primitive. So a domain primitive is a concept where each instance needs to be valid. And if you model, your code like that, we're going to be taking disadvantage, because here, when I'm creating my order now, which has order number as a field, I don't need to worry about order numbers. Where I'm invoking the fetch function from the gateway, I don't need to worry about order numbers. Where I'm calling the delete on the repository, I don't need to worry about order numbers.
Okay, I got it.
What the main difference that we had from the original example is before we use strings, and when we use strings, we could pass any string. But when we're using types like this, we cannot pass anything but this type. And if this type makes sure that the order numbers are always valid, then the consumer doesn't need to worry about this. Kotlin adds one nice feature that Java doesn't have, which is, in this case, order number cannot even be null. So we don't even need to check whether it's null or not.
Okay, thanks for the answer.
You're welcome.
There was a second question from you. Any help to the people working with dynamically typed languages?
Yes. Unfortunately, you need to rely a lot on linters there, but linters will help you. So they will be behaving, they will be doing the job of the constructor. So when you can still create your types, and then the linters are going to check. I don't believe that you can have the same level of safety as you can have in a strongly typed language like Java, Kotlin, Rust. But you can use linters in those cases.
Okay, thanks again.
Another thing I'm going to repeat here a bit, which I would like to stress out of an advantage, is that when we capture this logic, this validation logic in one place, it also improves a lot the documentation. If somebody new joins the team and they need to understand our business model, all they need to do is they go to the test of this business model, and they're going to see what makes this model valid or invalid. So in our project, when we need to ask a question, okay, what makes this? What's an order number, or why the second digit is like this or not like that? You can go in the tests, and the tests will going to tell you, they're going to describe what makes this valid or what makes this invalid, and we found this very, very useful. So
sorry, one last question. With the sealed classes, wouldn't you defer again validation to consumers? Every consumer needs to check whether we have a valid or invalid instance and act accordingly. You will also need to test both cases for every consumer, or am I missing something? No Kotlin knowledge here.
I did not understand the first part of the question.
With the sealed classes, wouldn't you defer again validation to consumers? Maybe Tillman can also clarify if there's
no, you don't have to, because here the valid instance, you see, it comes with its constructor, and the valid instance is checking to making sure that the given order number is valid. Here I only have one checked for simplicity. But if, for example, if the length is not 10, an invalid instance is returned. As you can see here, invalid is returned. And after all the tests, you get the valid instance. So with sealed classes, no, only valid instances are created. But then, just to show you, in here, instead of just having order number, if you go with the sealed class approach, you will have order number.valid. Order number.valid, order number.valid. And there you're saying that you want this specific variant of the sealed class, not any variant of it, but this one.
Okay, that answers it. Thank you. Thank you. I didn't know that you can use the instance as a type also, so that clarifies it.
Yes, sorry about that. And I originally, when I was creating these slides, I wanted to use the sealed classes, but as you see, just having the sealed class, and this is not complete. Here, I had to take out some code. You see, it takes quite some space from the screen, and the screen is what it is. Otherwise, the slides will be too small to read, and I'm getting very old.
All right, then there's one other question. Is the following correct? Domain primitives equal value objects / entities with validation?
They are, as mentioned here, they are very, very, very close. They are very related, yes. There are two main things that we need to appreciate, that we need to take care when we are working with domain primitives. One is that these are only, they represent only valid values. And when I say valid, if I have order number invalid, this represents the invalid subset. And the order number not valid only represents the valid subset. So whoever is consuming these types, they don't need to worry about them. And also, it's very important that we don't reuse them, in the sense that I don't have one type called name, and anything which is a string like, I use that one, because it will defeat one of its benefits. So basically, if you just have one domain primitives, which represent different business entities, sort of, you're defeating the purpose here, as we're gonna see in the next section. Any more questions?
Those were the questions so far. I think you can continue now.
So ambiguity. Unfortunately, it's in our nature to err. And Air Canada in 1983, not to blame nobody here. Actually, their pilot was very good. They had an issue where the aircraft was loaded half the amount of fuel expected. And this happened because the country, they switched from the imperial system to the metric system. And where somebody thought the fuel that was given to the aircraft was in a unit, in pounds, where it was in kilograms. And what happened was the aircraft was loaded half the fuel. And of course, halfway through, the pilot realized that it had no more fuel, and they had to land the aircraft. They did land the aircraft. Nobody was hurt in this accident. And to be fair, this was not just the problem here was not just caused about the error, but one of the gauges was not working neither, and the pilots knew about this. So they just relied on the papers that were given to them, which were misread basically by the pilots, unfortunately. NASA had a very similar problem with a sad outcome, where they lost the climate orbiter because parts of the code thought that it was talking to the system in imperial units, where the other part of the code was working with metric units. So, of course, if some part is communicating, the result is going to be bad. So these problems, they happen. These problems are real. And here I just mentioned two quite big incidents. Luckily, nobody got hurt here. But this part that we don't know, we don't understand the value that we have, it's quite common. So for this presentation, I am going to be using a demo example just to show the problem in code. So let's say that we have an air conditioner controller here, which has this function adjust power. It takes the power as a double, and it will adjust the compressor power accordingly. So now here, say that by mistake, instead of passing 18 degrees, we pass the Fahrenheit equivalent. So part of the code, in this case, is working with Fahrenheit, whereas another part of the code is working with Celsius. So by mistake here, we're calling the adjust power with the Fahrenheit value instead. The controller is gonna think that it's too hot, and of course it's gonna put the compressor on high power, on full power. How can we mitigate this problem? A very, very common approach is using enums, where we can put an enum here, the temperature unit, to define what unit we're using, and use a double. And this is quite good, because like this, whoever is calling the function has the responsibility at least to say, okay, I'm giving you this value and this is the unit. So if part of the code is working in Fahrenheit, all they need to do is, yes, pass the Fahrenheit value together with the Fahrenheit unit here. But of course we can do better. It went too fast. Yes. Instead of enums, we can use sealed classes as well here. So we can have a temperature class as a sealed class. We can have an abstract function to Celsius and two variants. One of them is called Celsius, the other one is called Fahrenheit. If we need more, units, all we need to do is add a different data type. How will this work? It's very simple. Each data class here, it needs to override the to Celsius function, because that's defined as abstract, and they need to do the conversion. Now, the conversion per se, it's not difficult to convert from metric to imperial, from Celsius to Fahrenheit, or from pounds to kilograms. These are quite easy equations. And in the two incidents that I mentioned, that was never the problem. The problem was that the team thought that we're working in a unit, and the other team thought we're working with a different unit. But here, each data class is going to be responsible from converting it to Celsius. So in the Celsius example, we just return itself, because Celsius doesn't need to be converted. But when we're in Fahrenheit, to Celsius, it needs to convert itself to Fahrenheit. And that's the equation. How can we use the controller? Now here in the controller, we're taking temperature, not a specific temperature. So we can take any temperature we have. However, so if on one end of the code, I need to work with Fahrenheit, it's not a problem. I can call this function. I can give it my Fahrenheit version. And then inside the adjust power, all I need to do is call it Celsius method. And then I am certain here that within my function, I am working with the right unit. So if by mistake somebody passed me the Fahrenheit value, I will convert it to Celsius, and that's it. I can rest assured that I am working with Celsius. This is beyond conversions. And here we have a classic example where by just reading a method signature, you don't know, or it's very hard for you to know what is this method, what each parameter is expecting. So let's say that we have this function where we use it to change or to set the date when something is dispatched. This function is going to take a day, a month, and a year. But which one is the day? Which one is the month? Which one is the year? And is it day, month, year? In America, we have month, day, year. And also the month field. Is it zero based, which means zero represents January, or January starts with 1? By just looking at the function, you don't know. And you can tell me, you can test these. Once I had a similar problem, and the test was 1st of January of 2000, for example, where the day and the month, they had the same value. And yeah, the result was good, because yeah, it was the 1st of January, for example, or the 2nd of February. And the test itself, even though like we had full coverage and everything, did not make the distinction between the day and the month. And the error was only caught in production. These can be eliminated by domain primitives, because in this case, we can have one that represents the day, one that represents the month, one that represents the year. Furthermore, we can have, instead of 3 fields, we can have one domain primitive called dispatched on. Or somebody can tell me, listen, why don't we use, for example, the normal Java date class or the JODA class? Yes, we can do that, but will any date, will any instance of the JODA be valid? And the answer is no, because in JODA or in Java time, you can create time from, I don't know, 1,000 years ago. Our system was not there 1,000 years ago. So not all date instances are valid. If instead we use one domain primitive here that captures what we believe are valid instances, that's going to save us validation, as we discussed before. Not just ambiguity, but also validation. This was a short question. Sorry, a short section. Do you have any questions?
There popped up one. What is the behavior of the code if we enter argument that not pass the validation?
Pardon me, can you repeat? Because my son is watching TV at high volume.
Of course. What is the behavior of the code if we enter argument that not pass the validation?
That is a business question, because it all depends on what you need to do. If we just want to fail, we can just throw an exception. But as we saw before, we can have, I'm trying to find the slide. We can do something like this, where if the value passed the validation, we do something with it. If the value doesn't pass the validation, we do something else. But this is a very much business related question, and it applies to the context, to your context, and what works in one example may not necessarily work in a different example. Does this answer your question? Are there any more questions?
Not to this section, but we had one question to the section before. Doesn't it bloat the code and the tests, because whenever you will use a value like a price, you will need to constantly wrap and unwrap the value of calculations, etc. Doesn't it make the code harder to write and read?
Yes and no. We're gonna touch this on the some of shortcomings, but it's gonna make the code harder. No, it's gonna make the code easier to read, because now each type tells a story. Like, this is not a string, it's an order number, and you can do things. For example, let's say that I have a credit card. I can have a credit card.pay, and instead of passing the credit card to the payment service, you can pass the payment service to the credit card, for example. You can change the logic. Bloated tests, no, actually it's the opposite, because the tests are gonna be only concentrated or related to the creation of the domain primitives. Whereas if you use the language primitives like strings, doubles, or what comes with the language, you need to write validation tests in every place where you're consuming them. So if you had 10 receivers, you need to write the same test 10 times, because you need to make sure, for example, that the order number is valid before deleted or before fetch it. You can tell me, like, I don't care, you know, I can fetch any string, and then that will give me an error. You need to be a bit careful there, because if by mistake somebody pass an order number forward slash something else, instead of fetching it, you may be doing something else to it. I know that you're going to tell me, yeah, but you should not, you know, modify something with a GET request. Yeah, that's true, but maybe you don't control the other system, and the GET request may be doing something else. I remember in the past, some, without mentioning names, but, you know, routers at home coming from big companies, you know, you could delete accounts or modify with GET requests, because that's what they did, and some attackers exploited that. So this is validating something before using it. It's going to reduce the attack surface. Any more questions?
Yes, there's one to regarding ambiguity. Why do you ask a temperature for its value in Celsius? According to the tell don't ask principle, you should instead ask for a temperature whether it is smaller than another.
Here the function, the adjust power, it works with Celsius. It doesn't care how it doesn't care in which unit the temperature was provided. And I'm not going into the details of the range because, to be fair, if we go back here, 18 degrees and 64, they are equivalent. And I cannot just check this is something greater than another. If parts of the code are working in Fahrenheit, and this part needs to work with Celsius because that's what the coders did in this area, I shouldn't force the other part to change their code, because they are basically saying the same thing. The only difference is the unit that they are using. So instead of doing the check, like if it's smaller than something, instead of assuming or making these, trying to turn, trying to make this fit or try to avoid the problem, if instead I use something like this, I won't have the problem anymore, because you can call me. I'm giving you the flexibility to call this function in any temperature unit supported. In this case, only Celsius and Fahrenheit. But then the consumer, it's gonna convert it to Celsius and work with the converted value. So here, inside here, I don't care what unit, this function doesn't care in what unit the temperature was passed, because then it's gonna call the to Celsius and work with the Celsius version. If we had the total opposite requirement where the adjust power works with Fahrenheit, instead of 2 Celsius here, I would have 2 Fahrenheit. And then the controller will receive the temperature in any unit, and it will convert it to Fahrenheit and work with Fahrenheit. Also,
well, my point is that the consumer should not be aware of any units because it doesn't need it.
The consumer, the adjust function, you mean, right?
Yeah.
But then you're going to have a bit of a problem because let's say that we are, based on the temperature, we are increasing the power of the compressor. So let's say if the temperature is between 16 and 22, you make compressor power 1. If it's between 23, for example, and 28, I'm just inventing numbers here, okay? You put it to power 2, and anything above to power 3. In this case,
yeah, I get that.
So if somebody gives you 64, the compressor thinks, it's too hot, because the compressor, it's the logic of the compressor. It's thinking with the Celsius values, not with the Fahrenheit values.
Yeah, but I think that the consumer, the adjust power function should not know anything at units, because units are not relevant here.
But if I program the adjust function in Celsius,
no, you should not do that. I mean, the adjust function will need a set value, and the set value is also a temperature, and it doesn't matter what unit it is, because the temperature knows what unit it is.
And you mean that when I create the temperature, I will only allow Celsius, for example?
No. The temperature can be anything. I can use any value, and of course I have to provide whether it's Celsius or not. But the adjust power function doesn't need to know that, because it will just compare it to the set value, and its set value is also a temperature that knows about the conversion and about whether it's larger or lower than the current value.
I see. Yes, you can do that. Yes, of course you can. Yes. Of course you cannot do it with the double. You need a class for it.
Right. Yeah, that's true.
Definitely. And then, if I'm not mistaken, in here, for example, you also can compare these. So you are able to compare Celsius with Fahrenheit, because they know how to compare themselves. Yes. Any more? Did I answer your question, first of all?
Oh, yes, thank you.
You're welcome. Any further questions?
No more questions so far. You can continue.
Great. I think this is the best part of the slides. I hope you agree too. Security. So how many times do we leak sensitive information? And this is just for us to blame, nobody else. Say we have a credit card. How many times we printed credit card details on a log file or passwords on a log file or something sensitive? Many times. And so let's say that we have this data class called credit card. We give it the value, credit card value. In this case, please don't use my credit card, okay? If you execute the statement, it's going to print the credit card value. So this can easily go on the logs. How can we prevent this? One simple thing we can do is, for this domain primitive, is we can override it to string function and we print the masked value instead. So here what I'm doing is I'm printing XXX and then just the last 4 digits. So whenever you receive something like on a letter at home, or on an email or something, just receive the masked value. Yes, but what if by mistake somebody does this? So here I am invoking I am bypassing the class and just going back to the value. This will still print the credit card number, and it went like it bypassed all our security. I think this is an area where domain primitives shine as well. And this is another small difference between domain primitives and value objects, because the goal of value objects here is just to represent some value, whereas the domain primitives are more about safety. Safety in the sense that valid values are created, not only that the values are used as best as we can in a valid way. There are limits to this, true, but values are used in the best, in the way they were intended to be used. Let's say that in our problem, in our context, the credit card number will only be read once. So once we get this from the database, we have it in some Kotlin or Java object, and then we only need to read it once, not twice. We shouldn't read it twice. This will be used once. How can we do this? What we can do is we can create something similar to the structure where we have a flag inside the domain primitive. And this flag, which is this consumed here, it's going to guard our data. If we read the data once, we get the value. If we try to read it twice, 3 times, more than the intended count, it will fail. So here, this domain primitive, it's not only making sure that valid order numbers are created, which of course the code is hidden from here for brevity reasons. Sorry about that. But it's also making sure that, or it's trying to limit the way it's used. So in this approach, if you try to read the credit card number more than once, more the intended value, it will fail. So in this example, the first print line will work, but the second print line will throw an exception. The second time is going to tell you the credit card number was already consumed. So if somebody by mistake tries to print it in the logs, try to do something more than was intended, the program will fail. And the most important thing is that the failures will not get unnoticed. And even during test, because if by mistake you put a log there and you try to get the value directly here for the credit card, when you run the test, the logs are going to be printed, and the part where you consume it more than you expected, it will fail, and errors will not get unnoticed. Is this a silver bullet? Will this solve all the security problems? No. Here's an example how you can fool around this. But again, in this example, we were not trying to protect against the evil developer, but we were trying to protect about silly mistakes that we usually have, and they cause our program to produce or behave in an unexpected way. So unfortunately, this is a way around it, because here we're reading the value once and then we're printing it 100 times. It's very hard to protect against this one. You need to change. It's very hard because the value itself needs to be passed to something else, and that needs to be read. But still, if you try to read it twice using this approach, it's gonna fail, and it's gonna tell you that this failed. So that concluded the security part. Any questions related to that section?
There were no questions popping up in the chat, so you can continue.
Very good. Tight coupling. It's also an interesting aspect, because sometimes we tie our code to domain primitives or some library primitives, and we tie them a lot into our business logic. And that can be, that can prove challenging in the future. This is an issue we had. We used the timer class in the code, and then we realized it's not the best candidate. And here we have our timer class. The timer class, unfortunately, if you throw an exception, a runtime exception from within the task timer, the timer will stop. But if you don't know this, you know, you're gonna code in it, and if you don't know it, you're gonna think that you have a scheduler where you don't. Now, let's say that you're using the timer class throughout the code, and you would like to replace it with a schedule executor or some other service. It's not gonna be as easy as you think, because you need to go in all parts of the code, you need to replace it, and then you need to make sure that the timer is still providing you the same business value that you had before. If instead you wrap these primitives into your own, like for example, cron job and cron job task, you hide yourself, you add a new layer between your business logic, your application, and the language primitives. Swapping internals would be way easier, because we just go inside the cron job and the cron job task, we do the changes there in these places, we run the tests to make sure that the cron job behaves as it needs to behave, and that's it. This also has another advantage, because let's say I am testing some other part which is working with the cron job here. I can safely mock it. You can tell me, yes, I can mock any data type, I can mock anything. Yes, but it's not always recommended to mock stuff which you don't own or stuff which you don't really know, because you may be doing assumptions that do not exist. As with what happened with the timer class here. Somebody that doesn't know that the timer class will stop working, you know, we may have mocked this, we may have added a test, threw an exception, and then we pretended it's gonna keep going, because we didn't quite understand it. Whereas in this case, this is our code, we have our tests, the tests are dictating the behavior, are documenting the behavior of these classes, and swapping the internal, their guts, it's gonna be way easier. Also, it's gonna be way easier because all this is gonna be centralized in one place. And of course, refactoring is going to be simpler, as for the same reasons I was discussing. Any questions?
Yes, there was one popping up. How do you know from which such situations to secure yourself? If you do that too much, I'd be wasting lots of time for something you'd never need.
I was going to talk a bit about this. If I think they are asking about the credit card example. If the person who wrote this is still in the chat.
No, not really. It was really about this timer and timer task thing.
Okay. What was your concern?
Here you are saying that if you knew before that you will have a problem with the timer, you would create a layer in between the Java util timer and your piece of code. But you don't know that when you're writing this code. You will know that once you get to a problem. But if you'd like to protect yourself from any kind of such a problem, you'd be wasting tons of time doing something that you will not get benefit of.
That's true. That's true. I'm gonna touch a bit about these benefits in the shortcomings, but since you asked, let me bring it here.
Don't worry, if you have it planned for later, don't interrupt yourself.
No, as you wish. It's okay for you if we discuss it at the end?
Yes.
Okay. Which is actually this section. So we can start with this. One thing that I would like to stress out, even before showing the shortcomings, is that don't take coding, or this is my advice, don't take coding religiously. Everything comes with a cost. So as this gentleman said here, that if you are gonna layer yourself too much, you're paying a price in terms of coding. So how would you know? Sometimes it will also come with experience, because for example, in this case, we had some logic here. So usually when I see some kind of logic like this, I protect myself, because this kind of logic, first of all, I need to test it. I need to make sure it's behaving in the way I want it to behave. Now, I know that maybe not everybody likes testing, but in reality, we're always testing, because if we try something in the code, like if we do something in code, what we usually do, we run the program and then we see that it's working as we want it to work. So instead of writing some code to test it, we are manually trying it out. So we're still spending the time there to try something. Might as well, we create the layer. If it's something trivial, if it's something which value is not much, should I invest there? No, you should be wise. You should pick like your battles. Like, should you just go out and change everything to domain primitives? No, that's a big mistake. You should think and you say, okay, if I have to change this, especially in an existing system, what's going to be the impact and what's going to be the gain? If the gain is going to be better than the impact, then yeah, we will do it. But if the gain is not going to be that much, you need to think about it. Domain primitives, I think they are easier if you start with them immediately. And they help you out, they'll make your system very much self-described. And yes, it may, as we're going to see here, it may make your stuff more verbal, like bloater. It may add more classes, yes, but it makes your system more robust and way more documented. Also, it removes ambiguity, and ambiguity is quite a big thing. So let's go to the shortcomings one by one. One of them is verbosity. Let's say we have this slice function that takes 2 integers. Of course, this function, it's way simpler, as it is, original.slice. But what is 1 and what is 2? Is 1 the first index and 2 is the second index, or is it the length? You don't know by looking at the function. And when you are working in projects and you're going to tell me, yeah, but I'm working with code I wrote. And if in my case, unfortunately, I forget code that I wrote a couple of weeks ago. We do so many different things that you'll forget what happened before. At least that's what happens to me. I know I'm getting old. But this, yeah, it's small, but you don't know what these two are. Whereas if you have this approach where the slice takes a range and the range takes a start index and the length, for example, or the range can take a start index and an end index, then the range will make sure that these two are, it will take the proper action. So if it's a length, it says, okay, I'll just add 2 to the start index. And if it's an end index, I need to make sure that one is bigger than the other. The original function, the slice function, sorry, here, there is no ambiguity, but it comes with a cost of verbosity. Some will argue that, yeah, but this will read better. So I don't know, but to be fair, yes, it's going to make the code longer. Another issue, which I was mentioned also before, is compatibility. And that I think Java and the JVM languages, they suffer a lot from this, because if I have my types, I cannot use my types in your code. I need to transform them either in your types or in common types. And yes, for example, if I have a person name, I cannot write this to the database. I need to change it to a string. If I need to have sent person name to a part of a response, this needs to be converted to a string. When I receive something, I don't just get this JSON and put it in a table. I need to get the JSON, parse it, create my objects, and then parse it back and put it into the tables. So yes, domain primitives, because these are your types, they are incompatible with other third-party, other libraries. And it can add some work here, because objects need to be parsed, marshaled, and unmarshaled. And you need to add tests for both ends to make sure that when you receive this format, like this input, it's being translated into the proper object, and then this proper object is translated back into the proper object to be written into a database. And these are additional layers that you need to incur. Another problem is class explosion. That, yeah, before you only had maybe a couple of services, now you have a couple of services and tens of domain primitives. And that can be quite annoying because you have lots of them. Again, there are those with the opinion when they say, yeah, but you know what? Like this, my software like talks. You don't have a string, you have a name. You don't have, a long, you have a credit card. So you know that this is credit card, and removes ambiguity. Yes, but as I mentioned at the beginning of the shortcoming section, everything comes with a price. So when we're buying something, we need to make sure that what we're buying is worth our money. And same applies to software and to domain primitives. They are no exception. So this brings me to the end of the presentation. But if you have any more questions, please feel free to ask me. One last thing, feedback makes us better. If you have any feedback about the slides, the presentation, by all means, please, you can either tell me now, or you can send me an email, or you can contact the organizers. I modified the slides actually following some feedback I've got, because they gave me a different input. So I definitely appreciate feedback, even if it's negative. Actually, that makes me be better. Last but not least, Thoughtworks is always looking for new talented people. This photo captures one of my dearest friends, Tom, who's in Singapore. I don't know if he's still with us because it's very late there. This was an away day of last year. Any questions?
So far, no questions popped up in the chat. They are thanking you for the great presentation.
Thank you, everybody, for attending. The weather was beautiful out there, at least in Germany. So it was a big sacrifice. I hope it was worth your time. And should you need to reach out, we're always here.
Thank you, Albert.